Welcome back to the second half of the Origin Symposium number 4 to do with hybrid arts. And in this section we'll we'll get presentations by 3 of the other winners of the hybrid arts category. And we'll start with Tuur van Balen, who was a designer, who uses design to explore political implications of emerging technologies through designing and experimenting with new interactions. He constructs thought-provoking new realities, both the process of creating those objects, interventions, and narratives, as well as the resulting physical presence, are aimed to confuse, question, and confront different publics with the possible and impossible role of technologies in our everyday lives. And Tuur won the Awards of Distinction for his piece, Pigeon d'Or, which, in the opinion of the jury, was the best representation and the most complete work to do with the new field of synthetic biology. And we commended him for, again, his rigor and seriousness in doing so, but also his very strong ironic undertones into questioning the whole idea of synthetic biology within the wider public realm. And I suppose Tuur will talk more about it. So please welcome Tuur van Balen.
Yeah, please do. I've got time here as well. Thank you, Oron, for the introduction. Oron sort of mentioned it a little bit, so I thought it'd be sort of useful if I give my personal explanation of what synthetic biology is. This is nowhere near scientific, and probably half of it's a lie. What is synthetic biology? Synthetic biology is the coming together of, where do I look there? Is the coming together of engineering and biology. So it sort of tries to apply engineering principles to biological entities, organisms. These engineering principles are sort of principles like abstraction, hierarchy, and standardization. And this thing you see on the slides there is one of the examples of what synthetic biology, this is sort of the wet dream of every synthetic biologist. It's the registry of standard biological parts. What it is, it's sort of like a box full of Lego blocks for biological organisms. So we kind of come to understand, for certain species like bacteria and yeast, we've sort of come to understand enough of their genome and the relationship between the genotype and the phenotype to not just read all of that information, but also start writing it, start tinkering with it. And the parts registry really is the kind of the toy box of synthetic biology. So if you go to partsregistry.org, that's a very exciting thing about it. Everyone can do this. This is just accessible on the internet. But if you go to partsregistry.org, you see this, the kind of interesting bit there is browse devices by type. So basically, they're kind of all these biological devices. And if you would click on the first one, protein generators, they're sort of like the reporters, almost like the LEDs of biosynthetic biology. You get a whole list of reporters. So these are all sort of synthetic biology little devices. Now, imagine you kind of scroll down that list, and then on the top one, in the second table, you can see Gfb Generator. It means it's a biological device that generates green fluorescent protein. It basically means if you implement this in a bacteria, it would start glowing green and glow in the dark. If you were to click on that one, you see the part number, you kind of see who it is designed by, you see the whole sort of, the logic of engineering oozes from this little website. And the most exciting thing then is if you were to, in that little purple bar, you click on Get Selected Sequence, BARF. This is the DNA code for that particular system. So this is the way synthetic biologists sort of kind of write little biological computer programs. They would then either have it synthesized or synthesize it themselves. If you have it synthesized, this is what sort of arrives in an envelope, and it's just a bit of DNA. Basically, you can buy these desktop DNA synthesizers that sort of look like the device on the left, and instead of, it's like a printer, that instead of printing CMYK, it prints ATCG, the kind of base pairs of DNA. That sounds funny, but it's actually really scary. And then you can implement that sort of little computer program you wrote into a bacteria, And you can sort of do that in a fairly clean kitchen. It doesn't take much to implement this in bacteria. And then you've got a little sort of biological device. You've got this little kind of biological machine that reproduces, grows, and it's living. So that's synthetic biology in a nutshell. Can we have more volume? A little bit? Yeah, that's cool. Thank you. So Pigeon d'Or really is a project that sort of in which I could pursue my interest in synthetic biology, and not just sort of the applications of synthetic biology, but I guess more the implications of synthetic biology. Kind of what would this really mean? And in the project, what I try and do is I set out to try and make a pigeon defecate soap. So what we did is I worked with a scientist, James Chappell. We designed and we created this bacteria that if you would feed it to pigeons, it would start metabolizing, it would start producing soap in its gut. So we don't actually do much to the pigeon itself, we just feed it this bacteria that would live inside the gut and would start metabolizing a sort of biological version of soap. And the project sort of came out of my interest in the sort of larger ecologies these technologies might end up in. So here is the part of the film you can see in the exhibition as well. And which, yeah, there we go. So we wrote this DNA code using partly existing biobricks to lower the pH, and we created a new biobrick. So we added, for this particular project, we added a biobrick to the standard registry of biological parts. And it's a biobrick that, when you would implement it into a bacteria, would start produce lipase. And lipase is an enzyme that digests grease. And so the lower pH in the digesting grease would sort of provide for a biological window soap. You can see next Y. So this is our biobrick in the Registry of Standard Biological Parts. It's designed by James Chappell, who's the scientist I work with in this project and earlier projects. And this is the DNA code. So in this project, I spent an awful lot of time hanging out with pigeon fanciers as well. And pigeon fanciers are people, they exist both in England and in Belgium, where I'm originally from. And they're people that keep a lot of pigeons for racing purposes. So this is Mr. Stratton. He's got about 70 pigeons in these two tiny garden sheds. This is somewhere almost close to the central of London. And I was really interested in kind of all of their knowledge of how to interact with pigeons. And all of this kind of knowledge that's not really considered science, but it does have this kind of great importance, not just for folkloristic purposes, because these guys, they earn a lot of money with breeding pigeons, they earn a lot of money with racing pigeons. It's got this whole sort of social, economical, cultural structure around it, which is kind of sits outside the culture we call science normally. and it's sort of great interest to me because it relates to this question of who's going to do synthetic biology. If it is such an accessible thing, as I've just tried to demonstrate in this kind of 4 mouse clicks down to the DNA code demonstration I did earlier, sort of who will be doing this stuff? And I believe that it shouldn't just be left to scientists. If it is so accessible, why not sort of open up this field to this wide diversity of practitioners, like amateurs in their garage doing synthetic biology, or artists, for that sake, to create the sort of nonsense some of them do. So I tried to kind of drain these pigeon fanciers with their sort of knowledge of how to interact with these pigeons, and kind of really using these pigeons as this platform and an interface for biotechnology, for synthetic biology, for this thing that's actually quite invisible to us. I created these sort of objects and scenarios in which I imagined what it would be like if we would live with these pigeons that would produce soap for us. So this is the first object which would allow you to keep these pigeons on your windowsill. And your window would sort of provide the interface between the inside and the outside. The outside being this kind of being the urban ecosystem, almost seeing the city as this organism these pigeons are part of. And the device sort of allows you to separate these pigeons and select them and sort of feed different pigeons different bacteria, put them together, which are all of these tools that these pigeon fanciers use at the moment to raise them. And sort of the geometry of the device is also derived from these geometry of the pigeon traps, which are the sort of physical devices they use to have them fly in and trap them inside so they don't come out. This is the device exhibited here, but it's on the outside of the Natural History Museum in Vienna, trying to catch pigeons. And this was the second scenario in which I imagined that you would have these pigeons trying to shit on your windshield of your car. So when you park your car, you would put this device on top of your car, feed them the bacteria, and then when you want to try, and they would defecate on your windshield, cleaning your window, and then they would you would just take the device off and drive off again. Now, I guess there's a sort of couple of questions, and one of them being why pigeons? And I was hugely interested in pigeons, partly because where I grew up, there was a lot of pigeon fanciers around. So I remember as a kid, all these pigeon fanciers every Sunday, which is when the race is, they would sort of stand there with a bucket of peanuts trying to get their pigeons to come in quicker to win the race. But on the other hand, pigeons are already these very, very unnatural animals. They're already sort of a very unnatural species. Pigeons over generations and years have been bred to come home quicker, either to deliver post or for racing purposes. And even Charles Darwin was very, very interested in pigeons for that reason, because they had such a controlled evolution. So on the bottom right, you actually see a drawing of Charles Darwin's pigeon loft. And on the bottom left is Richard Dawkins playing around with the taxidermy pigeons of Charles Darwin that are being kept somewhere in some sort of natural history museum somewhere in England. And I think, in a way, you could almost perceive, like you can almost think of pigeons as a product of biotechnology already, because we're just not using the synthetic biology or biotechnology as we know it, but through this kind of very, very controlled breeding. And obviously, even the pigeons we see in the city, the sort of pigeons that we now perceive as flying rats, they're only a few generations away from bred pigeons. So they're even sort of more unnatural, because they end up in this kind of ecology which is urban. And it results in this kind of strange architecture and technology we invented. So if you look around Linz and you look around Vienna or any European city, we came up with this sort of absurdist anti-pigeon technology, from like little spike and pigeon nets down to pigeon lasers that are meant to chase pigeons away. And then here's another pigeon that could sort of make you think, because the whole question of is this natural and is this sort of meant to be nature, it kind of annoys me a little bit, because because what is nature in the first place? That we have this sort of weird misconception of nature sort of being this balanced total system that we human beings will then come and disturb, which is sort of arrogant because it perceives the current sort of nature and state as the most optimal state. And so it sort of results almost in this kind of the use of nature and the use of ecology almost as this, as Zizek talks about, almost as this kind of this very conservative ideology. We kind of use nature, and this is natural, this is meant to be natural, we can't sort of touch this. And it sort of almost becomes this kind of new religion, I guess, in a way, whereas actually the reality of nature is just this kind of this messiness we don't really understand, and we've always sort of been part of, and you know, maybe sort of nature doesn't exist at all. I just ended 5 minutes before time. Thank you.